In this video, I'm going to be discussing code coverage and how to integrate that into an Angular project. If you've been following along with my previous videos, this is a continuation from the migration videos, migrating from Protractor to WebdriverIO. I'm continuing to use the Tour of Heroes tutorial project from Angular's website. The only difference that I've made so far is I've updated the Angular version to the latest version, 14.2.3. I've also updated the Chrome driver to 105 so that it matches my local version. I'm using Chromium. You might be using Chrome. So just make sure that your Chrome driver matches your local version. And as a reminder, it's easy to figure that out. Just open up your terminal and do Chrome or Chromium -- version and have a look at the major number. So in my case, it is 105. Before we jump into the code, let me talk a little bit about what code coverage is and isn't, and provide a high-level kind of technical overview of how code coverage is going to work in Angular. So code coverage, what it is it's a way to see what code paths have been executed in your project. In particular, what code paths are executed when we run our tests. So we're going to be running unit, component, and end-to-end tests, and we're going to use code coverage to see what's actually executed in our project. What it isn't is it doesn't really give us any indication of the quality of our code. It doesn't tell us if that code ran properly. It doesn't tell us if the expectations are correct. It doesn't tell us if the business requirements were met by the code that we've implemented. How I like to use it is when I'm designing a test and I go and implement it and execute it, I'll quickly take a look at how the code coverage changed and take a look at what paths were actually executed and try to figure out if those paths align with my expectations. If the code is doing something completely different, then it probably means that I didn't write the test properly or I didn't understand the business requirements, either writing the test or writing the actual code. So that's always a good indication that you need to go back and dig a little bit deeper into what's going on. I also like to use code coverage to get an idea of if I've missed anything in the test suite. So if I have 100 tests and I've executed them and I believe that I've got the product covered, I'll take a look at the actual code coverage and find out that I might be missing certain areas. So I can use that to take a look at reality, expectations versus reality. So that's how I use code coverage. Feel free to chime in, let me know how you folks use it or your experience with it. Love to hear some feedback. From a technical perspective, how this is going to work in Angular is we need to actually enhance our Angular project to instrument the code. And what that means is that we need to add some special JavaScript in the code that's going to record the paths of execution when we run our tests. Out of the box, Angular provides support for this for our unit and component tests, and I'll show you how that works in a minute. But for our end-to-end tests, especially since we've migrated from Protractor to WebdriverIO, that doesn't happen naturally. So we're going to have to do some customization, and that's the bulk of the work that's going to be in this video. So similar to my previous videos, I'm going to create a brand new branch. We'll call it code coverage. And we're going to jump into creating or installing some dev dependencies. All of these are related to getting coverage working. And let me walk you through what each of these things actually do. So one of the main things we need to do is to get our end-to-end tests to instrument the code, run coverage, and generate a report. So in order to instrument the code, we need to do that during the Webpack phase of building this project. So we need Webpack to actually go in there, instrument the code, and then serve that code up and run the end-to-end tests against it. That's how we actually generate code coverage. The way we do that is we're going to have a couple of special dev dependencies. We've got a custom Webpack dependency we're going to use. We're also going to be using this package called Istanbul. That is the actual code coverage package, as well as NYC. NYC is a command line front end for Istanbul. And then we're also going to use WebDriver coverage service. So this is a special service that is going to allow WebdriverIO to interact with Istanbul and generate code coverage for us. So all these things are going to come together once we do some initial configuration. And at the end of this, we'll also simplify some of this code so that it's real easy to kick off our unit, component, and end-to-end tests and get a unified coverage report. Let's go ahead and install each of these dev dependencies. I'm just going to copy and paste them. Let npm do its thing. And then we'll take a quick look at the diff just to make sure that things installed properly. So you can see we've got our custom Webpack. We've got coverage Istanbul loader, NYC, and our coverage service, our WDIO coverage service. So that looks good. That's what we expect. Back to our list of things. So the next thing we need to do is to create a custom Webpack configuration. This is what's going to actually use the Istanbul loader, and this is kind of the entry point into how our code is going to get instrumented. So we're going to create a new file in the E2E directory. Call it coverage webpack.ts. And I'm going to cheat a little bit. I'm going to copy some code over that I created previously preparing for this video, but I'll go ahead and walk through what this code does. So this is going to be a Webpack rule, and it's going to look at any JS or TS file that it finds in the source directory. And it's going to find that source directory by going up a parent directory. So we're in the end-to-end directory. It's going to go up to the root, and it's going to find source. So it's going to be anything inside of here, which is exactly what we want. This is our application code. And it's going to use this loader. And I'm not an expert in this, so please correct me if I'm wrong. I'm not an expert in Webpack, but from what I understand, there is a way to change the order of how loaders are executed. And in our Angular project, there's other loaders being used to build and serve up this project. And I'm adding to it. We're adding the Istanbul loader to the already existing array of loaders. And what we're saying here is we want this loader to run towards the end of the array of other loaders. And as I understand it, things can be kind of grouped up. So there might be other post loaders, and all of the post loaders get grouped up together, and then they have their own order of execution. Point being is the loader needs to run at the end, or at least towards the end of the build process. Like I said, if that's not accurate, feel free to comment, give me some feedback. Always want to learn more. All right, so that looks good. That should be what we need to get our code instrumented. Now we need to kind of wire all that stuff up. So we're going to go into our Angular JSON, and we're going to make some new build targets, and actually make some build configuration changes as well. So there's quite a few areas we're going to change, and I'm going to walk you through it. So angular.json, first thing we want to do is go towards the top of this configuration file, and we need to change the builder to be the custom Webpack builder that we just installed as a dev dependency. And again, I'm going to copy some code over. So it looks like this. So we've got our Angular builders / custom Webpack browser. That's all we need to change there. this is going to allow us to pull in the coverage Webpack TS configuration file in just a minute here. So the next thing we want to do is we're going to create a new configuration. So there's a development configuration, there's a production configuration. We're going to create an end-to-end configuration, and it's going to look almost identical to development. So we'll copy that. We'll call it EDE. And we're going to add one more property, and this is how we're going to actually pull in that configuration file. And so it's going to look something like this. Again, I'm going to copy some code, but I'll explain what it does. So we're going to add a custom Webpack config property. It is a property that takes an object, and inside of that object is a path property that points to the path of the configuration file. So in this case, it's in the EDE directory, coverage.webpack.ts. That's the exact file we just created. So that sort of ties those pieces together. This is a new build configuration that we're going to use in a little bit here. So the next piece is we're going to create a new build target. So we have our normal serve target, and we're not going to change that, but we are going to add another serve target, and this is for serving up the instrumented code. So we'll call it serve coverage. And as you can see, we're using the custom Webpack builder for a dev server. And we've got a browser target that points to the new EDE build configuration that we created. So build EDE points back to this. And that's what's going to tie together the use of this Webpack configuration. So when we run the serve coverage build target, it's going to generate instrumented code for us, and it's going to serve it up. So the last piece we need to do is actually modify the end-to-end build target. And this, if you were following my previous videos, I modified this in a previous one to use WebdriverIO instead of Protractor. So we're going to modify this one more time to have it generate code coverage by using that serve coverage build target. So it's just as simple as updating this to be coverage. And we'll do the same on this as well. All right, so that should tie it all together. So the EDE build target is going to use the serve coverage build target, which uses the EDE build configuration, which uses the custom coverage Webpack configuration file. So that's how all that ties together. That's going to allow the EDE build to instrument the code and serve it up. All right, let's take a look at my notes and see where we are. So that should cover all of this. So next up, we need to go and modify our WebdriverIO configuration to make use of the coverage service. And what's going to happen here is this is going to tell WebdriverIO to go ahead and interface with Istanbul to do the actual code coverage. All right, so let's open up WebdriverIO conf, and that is going to be in our EDE directory. And kind of towards the middle of the configuration file, line 142, if you're following along, you're going to find services, and all we need to do is add another element to this array, and that's going to be coverage. This coverage service comes from the dev dependency that we installed earlier. All right, next up, we're going to make some modifications to how the unit and component tests run. So we're going to go into our Karma config. We're going to modify where the coverage report is generated. So normally it wants to put it or at least by default wants to put it into a subdirectory. We're going to clear that out. We're just going to put the coverage report directly in the coverage directory. And then we're going to change this from HTML to JSON. And we're going to name the file. We'll call this coverage unit.json. So a couple of things going on here. Normally we could just generate an HTML file, and so we'll get a nice HTML report. However, it won't be unified. It'll just be the coverage that we have for our unit and component tests. So instead, what we want to do is create a JSON file for our unit and component tests. And in Angular's realm, the component and unit tests are not really separate things. They're all executed via Karma using the Jasmine framework. So those tests are going to be grouped up, and they're going to the results of them are going to go into the coverage unit JSON file. And our actual end-to-end tests, which we've just set up and configured, by default are also going to go into the coverage directory, and they're going to be in a coverage-final JSON file. And that's just default configuration. So we don't need to really modify or configure any of that. And we need them to be two separate files. If we didn't name this, it would also be coverage-final, and our end-to-end tests would overwrite the unit and component tests, and we don't want that. So they need to be separate. So that's why we're naming the file, and you'll see that we'll end up with two coverage files. And then at the end of this whole process, we're going to use NYC, which was also a dev dependency we installed, to merge the coverage files together and generate a single unified HTML report. All right, so that should be all we need here. And the next thing we're going to do, we're going to simplify how we execute these things. So let's go into package.json. And let's modify the test script. So we're going to actually do a no watch, and we're going to add code coverage. Like I said, Angular supports code coverage out of the box for its unit and component tests. And we are modifying this. We're no longer going to be watching for code changes and rerunning our tests. We're simply going to use this script to execute our tests once. The next thing we need to do is update the E2E script to do something kind of similar. So let me copy over what I have here, and I'll explain what this does. All right, so we're going to, like before, run our end-to-end tests, but they're going to run using the new build target that we just completed. After that runs successfully, we're going to run NYC, and we're going to generate a coverage report in JSON, kind of like I was explaining earlier. So the test target script is going to run its own coverage and generate a JSON report, and the end-to-end script is going to run coverage and generate its own report. So we're going to have two separate reports. And let me clear this out as well, and I'll show you what that looks like. So if we do an npm run test, it's going to run our unit and component tests. And we can already see that code coverage is doing something now. Because our Karma config has a text summary, it's giving us a summary to the console. So we can see that we've got some coverage going on based on our limited 4 unit and component tests. And that's great. Kind of expect the numbers to be low because we're not providing that much coverage via unit and component tests. We'll cover that in another video. But as you can see, coverage directory was recreated, and we've got the coverage-unit.json because of this configuration. So next, if we run the end-to-end tests, we're going to get something similar. So run E to E. So we've got our passing end-to-end tests, and as you can see, we now have a coverage final JSON file. So that's the end-to-end version of coverage. And if we go into these, we can kind of see that we've got a bunch of different files and the areas of code coverage. And if we look at the unit, it's a smaller set because the unit tests don't cover as much. The unit and component tests don't cover as much. All right, next up, let's close these, is to combine that into a single unified report. And I'm going to refer to my notes. And as usual, I'm going to explain what that does. So we're going to add a new script. We're calling it coverage. And we're going to use NYC one more time, but this time we're going to say generate a report based on the files that are in the coverage directory. So based on these two files, generate a report, and it's going to be HTML and a text summary. So NYC is intelligent. It's going to know that we've got multiple JSON files in here, and it will merge them together. So let's go npm run coverage. And as you can see, it does it pretty quickly. And we've got a combined report. We've got a text summary that's showing us overall coverage of our unit, component, and end-to-end tests. And you can also see in our coverage directory, we now have quite a bit of extra files in there, and that's because it generated an HTML report. So let's go Chromium, or Chrome if you're using Chrome, and we'll point it to coverage index. And this is where it gets really powerful. So as you can see, we now have a more graphical view of the code coverage. We've got our stats at the top. And we also have a breakdown of the coverage across the files and directories. So we can go into any of these and drill in to get more detail. So we can take a look at source and look at the main entry point into our application. And we can see that not all of it's covered, and it makes sense because we're not running in production mode and our tests don't generate any errors. So this code's not being hit, but that's what we would expect. We could come back and maybe create some tests that generate errors, and then we would probably see this be covered, and that could be useful if we wanted to test out some error scenarios. Let's go back though, and let's take a look at some of these other areas. So what's in here? We've got the hero component, and it looks like we're just about 50%, 42% covered. Not very good. Same sort of thing. We can kind of look at, well, what's going on here? So it looks like the hero component, for whatever reason, we're not calling the add method. We're not calling the delete method. So this is a great indication that we're missing some test cases. In some future videos, I'm going to go through and I'm going to walk you folks through how to improve code coverage here, how to reorganize the tests, things of that nature. So that will actually start to increase these numbers, and we'll use code coverage throughout that process to make sure that we're on target. All right, so let's go ahead and close out of that. We've got a couple of last little pieces to do. In particular, I find it important to add the NYC output to git ignore. This is generated code. So when we run our end-to-end tests, Istanbul and NYC are going to be creating some files in here. It's raw code coverage data that then gets converted into our JSON file and HTML files. So we want to add that to our git ignore because we don't want to be committing generated code. Similarly, we would want to ignore the coverage directory, but I believe that's already included in our git ignore, so we don't need to re-add it. So let's copy this into git ignore. And I like to keep it kind of towards the top with the other compiled outputs. And maybe we'll even put a comment in here, something along the lines of code coverage generated files. And just to make sure, yep, so under the MISC section of the git ignore file, there was already a coverage directory being ignored. So that's good. That's exactly what we want. We don't want to be committing generated code. All right, let's close some of this stuff up. And last but not least, we would want to commit this code. As I usually do, I like to take a look at the changes that were made and make sure that we didn't accidentally introduce anything unexpected. So let's walk through some of this. So the git ignore we just talked about, we added the NYC output directory, so that makes sense. Actually, let's do this. Let's do a kind of a header for this. We'll say something like implemented code coverage. And we'll add some notes. Added NYC's output directory, directory to git ignore. Added coverage, build, config, and targets. Let's take a quick look through here. All of these things make sense, hopefully. Yep. Oh, that jumped pretty far. Yep, the serve coverage we have in there, and we modified our end-to-end build target to use serve coverage. So all of those changes are what we expect. The Karma config we changed. Remember, we removed the subdirectory and we changed it from an HTML report to JSON so that later we can merge the two JSON files together. So that looks good, no other code changes. We're going to ignore the lock file since that's generated code, but it should always be committed. And maybe I'll talk about why that should be committed in a later video. The package.json, we made some modifications to the test and end-to-end scripts, and those all look good. We added coverage, and we added some new dev dependencies. There should be 4 of them that we added, and that all looks good. We added a new Webpack configuration file to generate the coverage. Well, in this case, to instrument the code. And then we modified our WebdriverIO conf file by adding a coverage service and no other changes. So that all looks good. Oh, and I forgot to add comments of all these things. My mistake. And yeah, we'll say something, updated Karma's config file to generate a JSON coverage report. Added dev dependencies, if I can spell this correctly, added dev dependencies for code coverage. Created a custom Webpack config to instrument the code when running end-to-end tests. And updated WebdriverIO's config to kick off instrumentation. Nope, that's not correct. I'm sorry. To kick off code coverage. Recording, let's say. And that should be good enough. So let's commit that code and publish the branch. All right, that should do it. If you have any questions, leave me some comments. Feedback is always welcome. Until next time, peace.